Okay, so week 7 is about 2 different kinds of approaches to causal analysis. One is difference in difference, and the other is fixed effects. In this first recorded segment, we're going to do difference in difference, and then we'll do fixed effects. So just to remind you from an earlier lecture, the usual sequence, and actually the one that many of you will follow for the class paper, is kind of turned on its head with these analyses. So typically, you start with a data set. You know, let's say it's a data set that you've got for in a lab you're working with, and you start wondering, well, how can I use this data set to answer a question of interest? And a lot of really good work has come out of that. But what a difference in difference and more generally kind of quasi-experimental approaches do is turn that on its head. So it's first thinking of events, policy events, or other kinds of events that create exogenous variation in a measure of policy interest. Okay, so all right, so we want to know if we've got some sort of event that creates variation in a policy or measure of interest, how can we then go out and find the data that enable us to take advantage of that event to address the problem in a finding what the impact is, a causal impact, in a pretty convincing way. So in the Curry and Walker analysis, the policy question is really what is the effect of auto emissions on birth outcomes, right? It's kind of a long-standing question. You've always had this battle between the car makers and environmentalists and public health people who want emissions reduced because they claim it's, and with a lot of data, that it's bad for health, in particular, in this case, birth outcomes. And if you think about the problem of estimating the effect of automotive pollution on birth outcomes, it's a tricky one, right? You could get a big data set. Let's say you get all the birth certificates in a state, maybe over a number of years. Birth certificates have addresses on them. Take the address, match it to different sources of data on pollution. There's now a really interesting data set that people at Berkeley put together, which within 5-kilometer areas all the way across the country, estimate what particulate matter is over time. So one of those kind of data sets, right? So you know where people live, you know what the pollution level is by some measure, and you can correlate that with whether the child was born low birth weight, which I believe is less than 3.5 pounds. Now, if you have just a cross-section of data, it's going to be really hard if you regress birth outcomes on pollution to be very confident that that's a causal estimate, right? Because there are all sorts of omitted variables, these Z variables down here, that might lead people to be living in neighborhoods that have particularly high levels of pollution, and that might also be producing birth outcomes. So structural kinds of issues restrict where people live. So it might restrict them to living in polluted neighborhoods, and at the same time might restrict access to healthcare and so forth. That would directly affect birth outcomes. So unless you have some sort of control, some sort of measurement of those structural issues and can control for them, a lot of the relationship between birth outcomes and pollution might not be a causal effect of pollution, but might be a causal effect of these underlying kind of structural factors. So a cross section won't do, and even just a time series past pollution predicting birth outcomes really doesn't solve this problem. So what Curry and Walker do is try to take advantage of a natural experiment that is related to the conversion of toll booths to E-ZPass systems, where instead of stopping at a toll booth, you stop, you idle your car, you pay the attendant a certain amount of money, and you get your little card stamped. Believe it or not, that all happened. Now it's E-ZPass, right? You have a little sticker on your window, and you pass under the sensors, and you automatically get charged. So there's no extra pollution generated there. In contrast, there was a tremendous amount of pollution generated when everyone was stopping at toll booths. So let me stop and set up the analysis. Okay, so here's my depiction of Pennsylvania and New Jersey. I hope no one's from either of those states and takes offense at my drawing. But the basic situation there that Janet and Scott took advantage of is that there's a turnpike system that goes from New Jersey across all of Pennsylvania. And along that turnpike, there are all of these toll booths. So back in, I don't know, 1980s, 1990s, I don't know when it was, when it became technologically feasible to have E-ZPass instead of people working at the toll booths and everyone stopping. They started rolling out conversions of these toll booths into E-ZPass kind of setups gradually across the turnpike system, right? So that's handy because it didn't happen all at once. If something happens all at once, then you can't be sure that there was something else that might have happened that you didn't measure that was really behind whatever change you were observing. But in this case, it played out over a number of years. So you could take advantage of the fact that there's that variation to really try to nail down what the relationship is between the switch to much less pollution, E-ZPass kind of toll booths versus the old stop and pay the attendant kind of toll booths. So the idea here is that if auto emissions are causing bad birth outcomes, then you ought to observe improvements in those birth outcomes when a toll booth area gets converted from manual to E-ZPass. And it ought to have the biggest effect for women who live closest to the toll booths. All right, so that's the kind of key variation we want to take advantage of. So what the analysis ends up doing is comparing birth outcomes, and this is difference in difference, right? The first difference is to compare before and after the change. So the idea is to get birth certificates for years and years, right? And the period over which you're getting the birth certificates coincides to this whole period when things were rolled out. So you've got several years before the conversion around each toll booth, and then several years after. So you kind of pool together all that information and look before and after the change, look at birth outcomes before and after the change to E-ZPass. And then because you know addresses on the birth certificates, you can also do the second difference, which is women living very close to a toll booth versus women living further away. And there are a couple of different definitions for this, but the one we'll talk about defines very close as within 2 kilometers of the toll booth. And then a bit further away is between 2 and 5 kilometers around each toll booth. So think of what we're doing here. We gather data on millions of birth certificates across all these years in these states, but we're throwing away 98%, 99% of those data because anyone giving birth who lived beyond 5 kilometers of one of these toll booths, they're out of the analysis. You're not interested in them. They might be part of description, but you end up comparing only the within 2 kilometers of one of these toll booths versus 2 to 5 kilometers of these toll booths. So, I'm fond of saying the advantage of big data when you have a gigantic administrative data set is that you can throw away 99% of it and still have a lot of observations to concentrate on the variation that's of interest here. And the variation that's of interest here is 2 differences, before and after E-ZPass, and for women living very close versus only fairly close to these toll booths. So that's the general idea. Let's talk about how the model gets set up in a second. Okay, so the actual model is run on this sample of a very small subset of birth records, just those associated with births for moms who are living within 5 kilometers, right? We're dividing less than 2 and 2 to 5. And the regression is very straightforward. It's low birth weight. That's one of the outcomes, whether or not the baby's weight was less than 3.5 pounds. And you're regressing that on a constant plus a coefficient times whether or not the conception, the prenatal period was a time when there was E-ZPass, that equals 1, otherwise 0. This is a dichotomous variable, a 1-0 variable. Plus, here's another dichotomous variable, whether the mother lived within 2 miles of the toll booth. And then the interaction between those two, right? B3 times the product of whether it's the prenatal period was during E-ZPass times whether the mom lived less than 2 kilometers away. So you're getting a main effect of the E-ZPass, non-E-ZPass distinction on low birth weight would be 1. You're getting the main effect of being within 2 kilometers versus 2.5 kilometers from the toll booth with this B2. But the key measure of interest is going to be this interaction, which is the impact of being both in a post E-ZPass period and living close over and above the main effects. All right, so if that combination is particularly potent, then it's going to be the case that E-ZPass made a difference that's bigger for the people who were within 2 kilometers of the toll booth relative to being 2 to 5 kilometers. So that's almost all there is to the model. It's a little bit more complicated, but if we look at their table, I had you interpret this minus 0.0093. The outcome here is low birth weight, and the yes down here indicates that we're introducing a bunch of maternal controls, which you'd want to do, and she includes without and with, or they include without and with, to see whether the results change when you introduce maternal characteristic controls. You'd hope they wouldn't, and in fact they don't. The second outcome here is premature birth, but let's concentrate on low birth weight. So the coefficient that's estimated is 0.0093. Now, this is a dichotomous dependent variable, right? Whether or not the birth was low birth weight. In the typical Cavalier economist tradition, this is just a regular linear probability model. You could have done it with Logit, but economists don't use Logit that often. Sometimes they do. It's actually more usually Probit than Logit. And this got published, so this is fine. This is kind of state-of-the-art methods. OLS is fine as long as you get the rest of it right. So let's think about this minus 0.0093. Is that a big change? Well, it's just less. It's essentially a 1 percentage point decrease in the incidence of low birth weight. So is that a big number or a small number? You really have to go back to the table that shows descriptive characteristics for the sample. And low birth weight, these are different subsets of the sample, but these are all about 9%, right? It ranges from 7.8% to 9.2%. So, around 8 to 9% of births in these areas of New Jersey and Pennsylvania tend to be low birth weight, 9%. So if we go down to our table 3, our key outcome table, you see it's the combination of being within 2 kilometers and after E-ZPass is reducing low birth weight by almost 1 percentage point out of a base of about 9%. So that's about a 10% reduction, and that's what the abstract highlights. If you go up to the abstract for the paper, so the introduction of E-ZPass reduced prematurity and low birth weight among mothers within 2 kilometers of the toll plaza by 10.8%. So they don't put percentage points. They express it as a function of the base. And then for low birth weight, it's 11.8%. So that 0.0093 was 11.8%. Of an increase, or a decrease rather, based on relative to the base of about 8 percentage points. And so they're featuring an estimate of within 2 relative to 2 to 10. I said 2 to 5. They've got various kind of sensitivity tests to show it really doesn't make much difference. It's always the case that the moms living close, on average, that the moms living closest to the toll booths are benefiting more than the people living somewhat further away from the toll booths. Okay, so that's it. I mean, it's a bit more complicated. If you spend a little time on the actual model, what they do is, one of the things they do is add maternal fixed effects. Which is the subject of the next segment of this week's class. And what that does, in effect, is identifies all of the births to the same women in the sample, right? So a lot of women in this sample, if they have birth records over a number of years, are going to show up more than once, right? They'll be showing up as many times as they gave birth. So it would be even sharper to have a third difference, which is among births to the same mother. Right, so you know, let's suppose one birth came after E-ZPass for moms living within 2 kilometers, and another one was before. So for that same mother, what is the change in the chance of low birth weight and prematurity? Or some of the moms moved. Sometimes they moved closer to the toll booth. Sometimes they moved further away. So it seems like for any particular mother, you're going to have you only have 3 or 4 observations at most. So how can you count on that? But we'll talk about later in this lecture, when we talk about fixed effects, that if you do those calculations that are very fuzzy for every individual mother, and then average them across thousands and thousands of mothers, you end up with a fairly precise estimate. And indeed, if you look at the table again, the coefficient was minus 0.0093, and the standard error was considerably less than that. So they have a lot of power in the sample to detect differences that are based before and after the change to E-ZPass for women living close and further away, and even among births to the same women. So all of those conditions kind of sharpen the contrast and make you more and more confident that what they've come up with is a causal estimate. And a lot of the paper is devoted to challenges to thinking about it as a causal estimate. And you can read the kind of counter arguments that people come up with, and what these papers tend to do during the review process. There might be 10 things that people think of. Well, maybe it's not pollution. Maybe it's house prices that's driving people away, and house prices go up after E-ZPass because it's better to live there. So they do a run that shows this setup applied to house prices really doesn't have any sort of significant impact. And just a bunch of threats to the potential validity of that minus 0.0093 coefficient as being a causal estimate. Okay, I would ask any questions, but I can't do that. So maybe we can talk about questions that you might have a week from tomorrow. So I want to keep going with one more example, and let me set that up and come right back. All right, so this is another example of difference in difference approaches. I have the link to the reading in the syllabus. It wasn't a required reading, but this is a policy brief, so it's easy reading, and it's very interesting, highly relevant to education policy, and it keys on the fact that after Hurricane Katrina, which was 2007 and horribly devastating for New Orleans, the public schools were totally wiped out, essentially. They all had to close, and it turned out that replacing the public schools was a product of state policy as well as local initiatives, that in place of the old public school system in New Orleans, arose charters, and almost 100% of the schools that started up again in New Orleans were charter schools. A lot of philanthropists who kind of championed charter schools were summoned to contribute to make this happen. So a number of charter school networks came in to New Orleans and set up shop, right? So there were all these charter schools, and within a few years after 2007, you had your choice of charter schools. I think there were one or two public schools that were an option, but that was it. All the rest were charter schools. So the policy question is, what are the impact of charter schools, in this case in New Orleans, post-Katrina? So think about this as a causal question. You've got charter schools coming after Hurricane Katrina, but they weren't there before, right? So it's kind of a pre-post charter schools, in the same way that the Curry and Walker article was pre-post easy passes. And you know, Curry and Walker had a comparison between moms living within 2 kilometers versus 2 to 5 or 2 to 10 kilometers from the toll booths. So to have the sharpest kind of comparison, you really want to be able to compare kids in charter schools in the New Orleans school district, almost all of which were charter schools, to a counterpart set of kids that were in very similar circumstances, right? So it turns out that the New Orleans school district is surrounded by other school districts, none of which went through this conversion to charter schools. So you'd really like to be able to compare how kids did after charter schools, the switch from public school to charter schools, relative to the kids who were in areas that were also devastated, right? They were right next to New Orleans, and Hurricane Katrina impacted their lives in almost to the same extent. And you really want to know to what extent the test scores, in this case, that's what they had access to, either improved or went down in New Orleans charter schools relative to these comparison schools. All right, so here again, we're throwing away a lot of data, right? They had data from all the school kids in New Orleans, Louisiana, from I think 2004 to 2014, all those data. And you want to throw away 98% of them in order to concentrate just on these school districts that were either New Orleans itself or adjacent school districts. So the idea graphically is, let's 2002 is when the data started. 2002 ending in 2014. So those are all the test score data that you have for all the kids in these school districts, as well as the rest of Louisiana. And this is achievement test scores. We'd really like to have a lot of other outcome measures, but test scores are what are measured. So 2007 is somewhere in the middle. This is Hurricane Katrina. You want to have a period of adjustment. So we're really going to say that things up until between Katrina and 2009 we're going to throw out because we want to know after things get settled back in after Katrina. So this is not going to be a period where you take test scores, but before, down to 2002, is going to be a period where you take test scores, and after 2009 is going to be a period when you take test scores. So in the policy brief, not only are there test scores, there's high school graduation rates, there's college attendance. So you can look at all those things. So think about what the data are going to look like in terms of average test scores. For non-New Orleans students, you know, there might be a change, but for the most part, this is close. This is not New Orleans, not NOLA, but adjacent. To NOLA. So they're going to be tracking in some way. And you really want to know where New Orleans is relative to these adjacent school districts. What you'd really like, red is going to be New Orleans. You'd really like to see patterns where before Katrina, you know, before anything really happened, you had similar trends. You know, maybe non-NOLA goes up, but you'd expect New Orleans to be going up too. You really want, Katrina hasn't happened yet, so you want to establish some baseline equivalence. But now the question is, after, are we going to observe a NOLA pattern that looks like this? Right, in which case the New Orleans charter schools are doing better than their counterpart non-public schools in these areas adjacent to NOLA, or are they going to look like this? In which case the charter schools are performing worse than the public schools nearby. So that's the basic setup. And what you really want to do, the regression setup is pretty straightforward here. You want to be able to track these test scores. You know, you really just have data points for the 2002 academic year, 2003, 2004. So we're just connecting those things. And then similarly afterwards, right? Every year you've got test scores. And similarly up here, you've got test scores. So the regression model is going to be test scores as a function of some constant plus B1, and let's, the key variable is whether NOLA, whether New Orleans. This is a 1-0 dichotomous variable. And now you want to allow for year-to-year variation, right? So you want, let's call it C1, whether we're talking about 2002, plus C2, whether 2003, plus C3, whether 2004. And now we're going to, well, 2005, 6, 7, C5, 6, 5 times weather 2006. But now we want to jump to C6, whether the first post-Katrina year you're picking things up, 2009. C7, weather 2010, plus 8, 9, 10, 11, C11 times weather 2014. So you just want a bunch of dummy variables for each of the years, but now the key interactions. So this is the difference in difference. Difference pre, difference post, difference between NOLA and non-NOLA. So let's do plus D1. And now we've got weather 2002 times weather NOLA plus, all the way out to D11, weather 2014 times weather NOLA. All right, and we can use this then to track what the pattern of difference is. And if the pre-Katrina trends are similar, we wouldn't expect to see very much of a difference between the NOLA schools and the adjacent school districts. So this interaction term ought to be small and insignificant. Once you get out beyond Katrina, that's what becomes interesting, right? For these interaction terms, if the charter schools in New Orleans are performing better than adjacent schools, this interaction term coefficient is going to be positive, and it's going to tell you how much better. This is this scenario up here, 2014, right? The coefficient D11 is going to be this difference in test scores, but it could be negative, which is going to be indicating this difference in test scores, right? So by tracking this pattern of coefficients on these interaction terms, right? Main effects are taken care of with B1 and the C's. The interactions are telling us whether the NOLA schools have a different time series than the non-NOLA schools. So that's the basic idea. And if you look at the policy brief, they have these graphs. That I'm starting with the ones that look the nicest, in the sense that what happens before Katrina, right? 2006-07, that's the school year when Katrina hit. So they go up to 2005, and then they start in again. Oh, I guess they start in again at 2007-08. So I didn't quite get it right up on the board. But this is showing, you can see the above figures show difference in difference estimates, dark lines, with confidence intervals, right? They're graphing the confidence intervals. And the other thing that they do is to, and we won't really talk about this very much, but for every child in New Orleans, in a particular, for every child in New Orleans in this year, this baseline year, 2005, they match them on the basis of test scores, right? Which is kind of exactly what you want. You want kids who look identical in terms of the full set of test scores that they've got. They use this technique called propensity score matching, which does the matching. And then carry the analysis kind of on these matched pairs of kids. So just prior, 2005, just prior to the to when Katrina hit, kids looked virtually identical in terms of their achievement. And so that's the 2005 point. There's no difference between them by construction. That's kind of the way this propensity score matching works. You can look before 2005 to try to see if in 2004 they had different science scores in this case, 2003, 2002. you know, there are, this confidence interval band is including 0, right? So it looks like the difference between New Orleans and adjacent school districts for these matched kids, the test scores looked essentially identical, right? So it looks like a pretty good comparison group. After Katrina, when we start picking it up again in 2007, 2008, they're still, this confidence interval includes 0, so you can't be confident that New Orleans kids are doing any better. But then you start getting these differences that are pretty big. This is more than half a standard deviation advantage for New Orleans kids relative to non-New Orleans kids on science scores. Same thing on social studies scores. Things look matched prior to Katrina, and you get a steady growing gap between NOLA charter school kids and adjacent public school kids, where the NOLA charter school kids are doing better by about a half a standard deviation. If you look at math and reading scores, you get a similar kind of picture. Things grow to half a standard deviation, 4/10 of a standard deviation. Here, there's a little bit of a more troubling, although it's never really statistically significant. You know, instead of having a pretty flat line here, which is what we saw with science scores and social studies scores, it looks like before Katrina in math, the New Orleans kids were improving a bit relative to the adjacent school district kids. So if their trajectory is positive, maybe some of this more positive trajectory is just a continuation of something that was going on before. You know, it's hard to say, but here, that doesn't seem to be the case. There, if anything, was a little bit of a negative trajectory for New Orleans kids relative to other kids. So take a look at this policy brief. Their administrative data include information on college entry. And they have fewer cohorts here, but not much going on before Katrina, but 10 percentage point higher college entry rates for the Katrina public school kids relative to adjacent kids. And I guess that's, oh, college graduation, there's not much data for that. But you know, the point here is not to think about charter school policy. There's a lot of twists and turns to the story of charter schools in New Orleans. But instead, the idea is to see how this event of interest, which is a conversion to charter schools, which would not have happened in the absence of Katrina. The public school system was very much in place and wasn't about to be changed, but Katrina forced that change. So you had this exogenous event producing charter schools, and you were able to take advantage of that because you had achievement score and graduation rate and so forth, college entry rate data available for kids. And in this particular analysis, what makes it convincing is that you're able to compare the kids who were in New Orleans going from public school to charter school to kids who live very close to New Orleans school district, were in adjacent school districts, went through the same kind of conditions from Katrina, but they stayed in public schools, right? So again, we're throwing away most of the data in order to concentrate on that subset of data with interesting, in this case, policy variation with the charter schools coming in. So lots of examples of difference in difference. And it's, you know, it's a a technique that you can't always apply to particular questions of interest, but if you keep your eyes and ears open, there might be events or policy changes that relate to what you're particularly interested in. And it might be interesting to think about a difference in difference approach to it, because it's likely to be considerably more convincing than just a typical correlational approach. Okay, so let me